This video is sponsored by NVIDIA AI. Imagine peering through a window into the farthest reaches of the universe, where stars are born, galaxies collide, and nebulas stretch across vast distances. The James Webb Space Telescope has turned that vision into reality, capturing images that reveal the universe in ways we've never seen before. Each image is a story, a glimpse into the cosmic wonders that have been hidden from view for billions of years. Let's journey through 16 of the most impressive Webb images that bring us closer to understanding the vast and mysterious universe. Before we begin, make sure to subscribe to our channel for regular space updates. Let's begin by diving into the beauty of the pillars of creation. These towering structures of cosmic dust and gas are among the most mesmerizing sights in the universe. Thanks to Webb, we can now see through these dense columns and witness the birth of new stars. These pillars, stretching roughly 7 light-years in height, are part of the Eagle Nebula, a stellar nursery about 6,500 light-years away. While the iconic pillars of creation first gained fame in 1995 when the Hubble Space Telescope captured them, Webb has revealed even more of their hidden beauty. Hubble's view was limited to visible and ultraviolet light, which cannot see through the cosmic dust and gas. So Hubble couldn't fully peer through the dense dust to uncover what lay inside. Webb, on the other hand, uses infrared light, allowing it to penetrate these dusty cribs and reveal newborn stars shining brightly within. In Webb's detailed image, these newly formed stars truly steal the spotlight. Along the edges of some of the pillars, you can see glowing red wavy lines resembling lava streams. These are actually jets of material being shot out by young stars. When these supersonic jets collide with the dense clouds of gas and dust, they create striking red waves. The light of thousands of stars twinkles throughout the scene, illuminating the towering pillars as they stand tall against the cosmic backdrop. Webb's view of the pillars of creation offers us an incredible glimpse into the dynamic process of star formation, showcasing the beauty and power of the universe in a way never seen before. The Southern Ring Nebula is a planetary nebula, which refers to the glowing shell of gas and dust that a dying star ejects as it sheds its outer layers. Located about 2,500 light-years away in the constellation Vela, this nebula had been previously captured by the Hubble Space Telescope. However, the James Webb Space Telescope's infrared instruments have now given us an even more detailed and stunning view of this celestial object. One of the key revelations from Webb's observations is a clearer image of the nebula's central stars. Previously, only one of these stars, the hot white dwarf, was easily visible, but Webb's infrared capabilities allowed astronomers to see both stars in the binary system with greater clarity. What's particularly striking about Webb's image is the complex structure of the nebula itself. Instead of a single ring, there are multiple concentric shells of gas radiating outward from the center. Each of these shells represents material ejected at different stages of the dying star's life. This layered structure reveals how the nebula is expanding over time, with stellar winds and radiation creating the chaotic yet stunning patterns we see today. The interplay between the stars and the ejected material offers a remarkable glimpse into the final stages of stellar evolution, transforming death into a beautiful cosmic display. One of the most delightful surprises from the James Webb Space Telescope was its spectacular view of Saturn. Typically, Saturn appears smooth and pale in visible light, but Webb's infrared image revealed the planet in a dark hue, with its bright rings stealing the spotlight. This contrast occurs because methane gas in Saturn's atmosphere absorbs most sunlight at the infrared wavelengths Webb uses, making the planet appear subdued. Against Saturn's shadowy backdrop, the icy rings steal the show, shining brightly and revealing their splendor. They appear as vibrant, thick, horizontal bands, glowing with a snowy hue, effortlessly upstaging the muted Saturn in the background. Made up of a mix of ice and rock particles, varying in size from mere grains of sand to towering mountains, they reflect a significant amount of infrared light. In this image, Webb captured the A, B, and C rings, along with the fainter F ring, and even details such as the Cassini division and the Encke gap, thin regions of space separating the rings. Astronomers noticed two mysterious things in this image of Saturn. First, they observed an unusual glow along the edges of the planet's disk, possibly caused by methane fluorescence. This is a process where atoms absorb light and emit it at a different frequency. Another theory suggests it could be due to emissions from trihydrogen ions, which are abundant in Saturn's upper atmosphere, or it might be a mix of both phenomena. The second mystery lies in curious patches seen in Saturn's northern hemisphere. These patches may be caused by gravity waves interacting with aerosols in the upper atmosphere, but the exact process remains unknown. Webb's image also captured 3 of Saturn's moons: Enceladus, Dione, and Tethys. Enceladus, in particular, fascinates scientists because of its potential for hosting life. Beneath its icy surface lies a subsurface ocean, and the moon's geysers regularly eject water vapor into space, contributing to Saturn's faint E ring. This makes it a key target in the ongoing search for extraterrestrial life within our solar system. When the James Webb Space Telescope captures its breathtaking images, they don't start out looking as stunning as the final versions we see. Astronomers take raw data, infrared light that our eyes can't see, and through processing and colorization, they bring these celestial wonders to life. It's a fascinating transformation, taking something invisible and turning it into a vivid masterpiece. Now imagine if you had a tool that could help bring your ideas and creativity to life. This is where InVideo AI's new V3 update comes in. You bring the idea, and with a single prompt, InVideo AI V3 handles everything, from scenes, music, and voiceover, all the way to making the video ready for every platform. It's like being in the director's seat, whether you're crafting a cinematic story about the universe or exploring the wonders of Earth. Let me show you just how easy it is. Watch as I type in, make a 1-minute video of the story of a robot in a cyberpunk setting that wants to escape the Matrix.
There existed a robot named Nexus, born in a dingy back alley workshop.
With InVideo AI's new generative capabilities, the entire process feels like magic. You can also change anything in the video, like adding your own voice. Whether you're a content creator, a teacher looking to make lessons more engaging, or someone who simply wants to share a meaningful story with friends or family, InVideo AI brings your vision to life. And the best part? InVideo AI V3 is launching soon, and if you haven't tried their current version yet, you can try it out for free and use my code to get twice the number of video creation minutes in your first month. So check out the link in the description and take your creativity to the next level. This image represents one of the deepest and most detailed views of the universe ever captured in infrared light, an extraordinary glimpse into the distant cosmos. It features SMACS 0723, a massive galaxy cluster located about 4.6 billion light-years away in the constellation Volans. Known as Webb's first deep field, this breathtaking image showcases thousands of galaxies, including some of the most distant ever observed. The image demonstrates the power of gravitational lensing, a phenomenon where the immense mass of SMACS 0723 bends and magnifies light from even more distant galaxies behind it. This cosmic magnifying effect has allowed Webb to peer back in time, observing galaxies as old as 13.1 billion years, formed less than a billion years after the Big Bang. The detail revealed by Webb in this image is unprecedented. Many of the galaxies within it represent some of the farthest ever detected. Residing over 13 billion light-years away, the ability to see these ancient galaxies allows scientists to explore the early universe, gaining valuable insights into how galaxies formed and evolved. This image, released in July 2022, was the first full-color image from the James Webb Space Telescope and serves as a powerful demonstration of its extraordinary capabilities. What you're looking at is the aftermath of a stellar explosion whose light reached our planet about 340 years ago. This is Cassiopeia A, a supernova remnant located approximately 11,000 light-years away. The JWST images reveal a complex tapestry of gas and dust, highlighting the remnants of the exploded star. The inner shell of Cass A is depicted with vibrant colors, bright pinks and oranges, that represent various elements such as sulfur, oxygen, and neon. These elements were expelled during the supernova explosion and are now visible due to JWST's advanced infrared capabilities. The outer edge of Cass A appears ghostly in near-cam images due to cooler dust that emits less infrared light compared to the brighter emissions captured by MIRI. This contrast illustrates how different temperatures affect the visibility of cosmic materials. Among the most fascinating discoveries in this image is a feature dubbed Baby Cass A. This is a light echo, essentially a blob of dust, being illuminated by energetic photons from the original supernova explosion. Baby Cass A sits about 170 light-years behind the main remnant and shines brightly in the infrared due to the heat from these high-energy photons. The entire Cass A spans 10 light-years across, or 60 trillion miles. With Webb, we can now see how the dying star absolutely shattered when it exploded, leaving filaments akin to tiny shards of glass behind. Neptune, one of the least explored planets in our solar system, has long been a mystery due to its sheer distance from Earth. However, the James Webb Space Telescope provided a stunning new view of this distant ice giant, revealing details never seen before. One of the most exciting aspects of Webb's image is the sharp view of Neptune's rings, something we haven't seen this clearly in over 35 years. The last time Neptune's rings were visible with such clarity was in 1989, when Voyager 2 made its historic flyby. Even advanced telescopes like Hubble struggled to capture the faint rings due to their low reflectivity and Neptune's great distance from the Sun. Using its near-infrared camera, Webb captured the intricate structure of Neptune's rings in incredible detail. It revealed not only the main rings, but also some fainter dust bands that surround the planet. These rings are made up of dark, ice-coated particles, which appear much more visible in the infrared spectrum, where Webb excels. This makes the Webb image of Neptune's rings the best we've had in more than 3 decades. Another fascinating detail from Webb's image is Neptune's appearance itself. While Neptune is usually depicted as a striking blue in visible light due to the presence of methane, it appears whitish in JWST's images. This is because methane absorbs light in the infrared spectrum, making the planet appear darker at these wavelengths and leaving behind a ghostly white appearance in the image. We can also see bright cloud formations in Neptune's atmosphere, particularly around its poles. These bright spots are high-altitude methane ice clouds, similar to the icy clouds seen on Earth. A thin line of brightness circling the planet's equator could be a visual signature of global atmospheric circulation that powers Neptune's winds and storms. In addition to Neptune itself, Webb captured a breathtaking view of Triton, Neptune's largest moon. Triton appears as a bright point of light, even brighter than Neptune, in this infrared image. This is because Triton reflects far more sunlight in the infrared, whereas Neptune's methane-rich atmosphere absorbs much of the sunlight at those wavelengths. Triton's standout brightness, combined with Neptune's new details, makes this one of the most spectacular images of the ice giant and its moons ever captured. Released as part of the first batch of science images in 2022, the Cosmic Cliffs is a stunning region located within the Carina Nebula, about 7,600 light-years away. Webb's image of this area offers a dazzling, seemingly three-dimensional view, resembling craggy mountains illuminated by moonlight. In reality, the image shows the edge of a vast gaseous cavity within NGC 3324. The tallest peaks seen in the Cosmic Cliffs stretch about 7 light-years high, which equates to a staggering 42 trillion miles. These cliffs have been sculpted by the intense ultraviolet radiation from massive O-type stars just beyond the frame of the image. These young hot stars blast out radiation and stellar winds that push gas and dust away, carving out the cosmic landscape seen here. Webb's infrared capabilities revealed numerous young stars and protostellar jets, which are streams of gas being ejected from stars still in the process of forming. These jets, visible as bright streaks across the image, mark the areas where star formation is actively occurring. In fact, astronomers have detected 24 new outflows of molecular hydrogen in this region, further evidence of the intense star formation activity within the nebula. What's remarkable is that many of these stellar nurseries were previously hidden from view by thick clouds of gas and dust. The Cosmic Cliffs are not just visually striking, they provide valuable insights into how stars are born and how their intense radiation carves the surrounding nebula, shaping future generations of stars. Next on the list is Webb's deep field image of Pandora's cluster, located about 4 billion light-years away. This image represents a significant achievement, combining 4 individual snapshots into a sweeping panoramic view, revealing an incredible 50,000 sources of near-infrared light. A surprising fact is that the galaxies within Pandora's cluster only account for about 5% of its total mass. A much larger portion, around 20%, is composed of hot gas, which is so heated that it emits X-rays. However, the majority of the cluster's mass, roughly 75%, is made up of dark matter. One of the most remarkable features captured in this image is the phenomenon of gravitational lensing. The immense mass of the galaxy cluster bends and distorts light from even more distant galaxies behind them, effectively acting as a cosmic magnifying glass. This lensing effect allows astronomers to observe galaxies that would otherwise be too faint to detect. In the lower right corner of the image, numerous arc-like streaks can be seen. These are the distorted, magnified images of distant galaxies, giving us a rare glimpse into the structure of the early universe. Pandora's cluster, with its complex gravitational interactions and dark matter dominance, offers a fascinating window into the cosmic forces shaping the universe. Next on the list is the Grand Design Spiral Galaxy, known as the Phantom Galaxy, or M74, located approximately 32 million light-years away in the constellation Pisces. This galaxy exhibits a textbook spiral structure with prominent sweeping arms that extend outward from its bright central core. The James Webb Space Telescope has captured these arms in exquisite detail, revealing them in rich shades of orange, indicative of regions dense with star-forming material. These dusty arms are teeming with the ingredients for new stars, creating a dynamic environment for stellar birth. At the core of the Phantom Galaxy, Webb's image shows a blue light haze, which signifies the presence of older stars. This central region is densely packed with star clusters that collectively contribute to the galaxy's brightness, forming a brilliant, glowing hub. This is not the first time the phantom galaxy has been imaged. The Hubble Space Telescope had previously captured striking views of M74 invisible light, showcasing its classic spiral structure and highlighting the distribution of stars and star-forming regions. In Hubble's images, the arms of the galaxy glow with blue light from young, hot stars, offering a vivid glimpse into the regions where star formation is most active. However, Hubble's observations were limited by its inability to penetrate the dense clouds of dust and gas that obscured parts of the galaxy's inner structure. In contrast, JWST's infrared capabilities allow it to see through these dust clouds, providing an unprecedented look at M74's inner workings. This enables astronomers to pinpoint specific regions where new stars are being born and to analyze the chemical composition of these areas in great detail. On July 27, 2022, the James Webb Space Telescope captured an extraordinary view of Jupiter, revealing details that had never been seen before. In Webb's images, Jupiter appears in enchanting shades of light pink, dusky blue, and white, colors enhanced by the telescope's infrared capabilities, which can penetrate the planet's thick atmosphere and provide insight into how different cloud layers reflect sunlight. The bright equatorial zone stands out prominently in these images, its high-altitude hazes scattering light and creating a striking contrast. Jupiter's iconic Great Red Spot, a massive storm larger than Earth that has been churning for over 350 years, is clearly visible. Interestingly, in Webb's view, the Great Red Spot appears white rather than red due to the bright reflection of sunlight off high-altitude clouds in the infrared spectrum. One of the most exciting features Webb uncovered was Jupiter's spectacular auroras, glowing brightly at the planet's poles. These auroras are caused by charged particles from the Sun interacting with Jupiter's powerful magnetic field. Because Jupiter has a much stronger magnetic field than Earth, its auroras are far more intense and extend over vast areas of the poles. Webb's infrared vision also provided an impressive view of Jupiter's faint rings, which are far less prominent than Saturn's, but still fascinating. These thin, dusty rings, first discovered by the Voyager spacecraft in 1979, are made mostly of small particles of rock and dust. They are believed to originate from impacts on Jupiter's moons, where material from these collisions has spread out to form the delicate ring system. Webb's images of Jupiter not only showcase its beauty, but also offer a wealth of information about its atmospheric dynamics, magnetic fields, and the forces shaping its environment. This tiny red dot you see is Earendel, the farthest star ever discovered in the universe, lying near the edge of time. The light from Earendel has traveled an astounding 13 billion years to reach us, but due to the expansion of the universe, its true distance is much farther, about 28 billion light-years away. This incredible discovery is a result of a cosmic coincidence, where the alignment of a massive galaxy cluster in the foreground has gravitationally lensed Earendel's light, magnifying it and allowing us to see this distant star. Earendel was first identified by the Hubble Space Telescope. Hubble spotted its host galaxy, which was being gravitationally lensed, forming a stretched and bent structure scientists named the Sunrise Arc. Within this arc, they detected something unusually bright, far too small to be a galaxy. Upon further study, astronomers determined that this bright object was magnified by a factor of at least 4,000, indicating that it was an extremely distant, gravitationally lensed star. Based on Hubble's observations, Earendel was classified as a massive B-type star, about 1 million times brighter than our Sun and more than twice as hot. However, when the James Webb Space Telescope observed Earendel, it revealed something new. Webb's advanced infrared capabilities detected hints of a cooler, redder companion star near Earendel, which had not been visible in Hubble's earlier observations. This discovery opens up exciting possibilities for studying this ancient stellar system. Earendel's discovery is monumental because it might provide our first glimpse of a population 3 star, one of the very first stars to form after the Big Bang. Population 3 stars have been the focus of astronomers' attention for years, as these stars were made entirely of primordial hydrogen and helium and may have played a key role in the evolution of the early universe. Astronomers expect that Earendel will remain magnified for years, allowing the James Webb Space Telescope to conduct more detailed observations. These follow-up studies could help unravel the precise nature of this star and its companion, offering us a rare window into the earliest eras of cosmic history. While Earendel represents a star born near the dawn of time, this image shows a protostar on the verge of beginning its life. L1527, nestled within a dark cloud. This protostar is hidden within a striking hourglass-shaped structure with a dark line across its center, representing a protoplanetary disk. Light from the forming star leaks through the disk, illuminating the surrounding gas and dust. In the near-cam image, the colors blue and orange represent different layers of dust. Blue areas signify thinner dust, allowing more light to escape, while the orange regions represent denser pockets of dust, where light is more absorbed. This color contrast beautifully illustrates the complex interactions between light, gas, and dust as the protostar matures. L1527 is around 100,000 years old, making it a very young Class 0 protostar, one of the earliest stages of star formation. At this stage, it has not yet begun nuclear fusion, the process that powers fully developed stars. As L1527 continues to accumulate mass, the material in its core will compress, eventually reaching the critical temperatures needed for nuclear fusion to ignite. This will mark its transformation into a fully fledged star. This view of L1527 offers a rare glimpse into what our Sun and Solar System may have looked like in their infancy, providing valuable insights into the early stages of star formation and the processes that lead to the creation of stars and planets. Uranus is one of the least explored planets in our solar system, with only Voyager 2 having flown past it. However, Webb's detailed images of this ice giant reveal features that were previously obscured. One of the standout details is the planet's vibrant rings, which had only been imaged by 2 other facilities, Voyager 2 and the Keck Observatory with advanced optics. Webb's infrared capabilities allow it to capture the brightness and structure of Uranus's rings, which are harder to detect in visible light. Among these is the elusive Zeta ring, which has now been clearly resolved, giving astronomers a better understanding of its characteristics. Uranus has 13 known rings, and 11 of them are visible in Webb's image. Some of the rings are so bright in the infrared that when viewed close together, they appear to merge into a single, larger ring. Another fascinating feature captured by Webb is the ice giant's polar caps. Uranus is unique among planets in that it rotates on its side, with its axial tilt of 98 degrees. This extreme tilt causes Uranus to experience very unusual seasons, with its poles undergoing long periods of constant sunlight, followed by years of complete darkness. Currently, it's late spring for Uranus's North Pole, which is visible in Webb's images, and the planet's northern summer will arrive in 2028. In contrast, when Voyager 2 visited Uranus, it was summer at the southern pole, which is now in complete darkness, out of view, and facing the vastness of space. Webb's image also captures several of Uranus's 27 known moons, including some smaller moons that appear close to the rings. Remarkably, this detailed image of Uranus was captured during a short 12-minute exposure using just 2 filters, demonstrating that this is only the beginning of what Webb can reveal about the mysterious ice giant. This is ARP 142, affectionately known as the Penguin and the Egg. In this stunning image, we witness the cosmic dance of two interacting galaxies, NGC 2936 and NGC 2937. While our Milky Way and Andromeda are separated by 2.5 million light-years, the Penguin and the Egg are just 100,000 light-years apart, which is relatively close in astronomical terms. The Penguin galaxy, originally a spiral galaxy like the Milky Way, has become significantly distorted due to its gravitational interaction with the Egg, which is a more compact, elliptical galaxy. Over the next several hundred million years, these galaxies will merge into a single entity, creating a dramatic, though gradual cosmic event. This image vividly captures the intricate interaction between the two galaxies. The Penguin galaxy, with its tail filled with gas, dust, and newly formed stars, has been transformed by the encounter. A bright blue haze surrounds it, indicating star formation. The beak of the Penguin is rich in gas and dust, and it is the brightest starburst region, where active star formation is happening. The eye of the Penguin, seen near the galaxy's center, reflects the original spiral shape before the interaction with the Egg. The Egg, by contrast, is an elliptical galaxy with aging stars. Its compact structure and lower amounts of gas and dust have left it less distorted than its counterpart. A third galaxy, a spiral in the top right, attempts to steal the spotlight in this image. Though it appears prominently in this composite image, it's much closer to us and is not part of ARP 142. As these galaxies continue their cosmic merger, they will create new regions of stars and planet formation. This duo of interacting galaxies commemorated the second science anniversary of the James Webb Space Telescope in July 2024. There's a big crisis in cosmology, and this image taken by the Webb telescope confirms it. It shows galaxy cluster G165 acting as a massive gravitational lens, bending and magnifying light from distant objects behind it. But something surprising caught astronomers' attention in this image: three mysterious dots of light that weren't visible in previous Hubble images from 2015. These 3 points of light, now clearly visible in the Webb images, turned out to be a Type 1a supernova in a distant background galaxy. Named Supernova Hope, this exploding star has been gravitationally lensed by the cluster G165. What we see are not three separate supernovae, but multiple images of the same supernova whose light has traveled along three different paths, bent by the mass of G165 lying between us and the distant galaxy. This is a stunning example of gravitational lensing, where light from a background object is bent by the gravity of a massive foreground object, resulting in multiple magnified images of the same event. What makes Hope especially significant is that it is now the most distant Type 1a supernova ever observed. Type 1a supernovae serve as standard candles in cosmology, objects with known intrinsic brightness, allowing astronomers to accurately measure distances across the universe. These measurements are key to determining the Hubble constant, the rate at which the universe is expanding. However, there's a growing tension in cosmology. Webb's observation of this supernova has helped astronomers calculate a Hubble constant of 75.4 kilometers per second per megaparsec. This value, derived from the local universe, is in conflict with the Hubble constant measured from the early universe, using data from the cosmic microwave background, which gives a lower value. This discrepancy has led to the so-called Hubble tension, suggesting that there might be something fundamental missing in our understanding of the universe's expansion. The discovery of more distant supernovae, like Hope, will be crucial in refining these measurements and possibly resolving this tension in cosmology. One of the most breathtaking results from the James Webb Telescope came when it peered at the edge of time. Within weeks, The telescope observed massive galaxies at a record-breaking distance, challenging our current models of astrophysics. This is JADE's GSZ 14-0, the most distant galaxy ever observed, existing just 290 million years after the Big Bang. This means that its light has been traveling for approximately 13.5 billion years to reach us. The galaxy is not only distant, but also remarkably bright and large, measuring over 1,600 light-years in diameter. This luminosity suggests that it is producing light through young stars rather than a supermassive black hole, which is typically responsible for the brightness of quasars. The presence of ionized gases like oxygen indicates that multiple generations of massive stars had already formed and died before we observed this galaxy. The existence of such a large and luminous galaxy so soon after the Big Bang suggests that galaxy formation occurred much more rapidly than previously thought. This finding challenges existing models that predicted slower formation rates during this period. These amazing images from the James Webb Space Telescope show us the beauty and mystery of the universe like never before. Each image takes us deeper into space, revealing stars, galaxies, and nebula in incredible detail. They remind us that we are just a small part of a much bigger story, a universe that stretches beyond our imagination. Looking at these wonders, we can feel connected to the cosmos, realizing that the same forces shaping distant stars also shaped us. The universe is vast, and these images let us glimpse into the endless beauty and our place within it.